Key question A. Mr. Alvarez I recommend you read aloud with your finger on the paper, even as I read aloud, the finger on paper. Don't make me do the reading for you. Read, finger on paper, along with me. Ready? Out loud, read. Now you want to go back and highlight the keywords and phrases. The fact that we have 3 congruent half circles, that's important. Tight rectangular area. They'll be surrounded by ground cover, the shaded region. So this is the ground cover. The length of the rectangle is 54 yards, which we have right here. Find the area of the shaded region. The ground cover itself comes in flats of $4.50 each. So each flat is $4.50. And each flat covers 2.25 foot squared. So each flat is an area of 2.25 foot squared. Keep in mind that 1 yard is 9 feet squared because it's 3 feet by 3 feet. Keep that in mind. So in this problem, in order to get the green, you should basically realize that we're going to find the area of the rectangle. And we're going to find the area of the circles. So the area of the rectangle. And the area of the circles. And you should see, to get the shaded region, you essentially subtract those items. That will get you the shaded region. So you want to write down the equations for each of these. And for a rectangle, of course, your area is your length times your width. And for a circle, area equals pi r squared, but these are half circles, so you're going to take that and divide by 2. And then there's 3 half circles. So you times by 3. Problem 2. Put your finger on the paper. Right there, out loud, read. All right, so it says we have a rectangle inscribed in a circle. Inscribed means the corners are touching. The length of the rectangle, length, is twice the width. So it's 2 of the width. This would be your width. Length is 2W. We want to find the area, the perimeter of the rectangle is 36 inches. We want to find the area of the shaded region. Well, to find the shaded region, we're going to be finding the area of the circle. And we're going to find the area of the rectangle. And subtract to get the area of the shaded region. And we want this in exact terms, no decimal. So you may not use a calculator. But the perimeter is 36 inches. So we know this. The perimeter is going to be length plus width plus length plus width. And from here, you can circle, plug, check. C. Your right finger right there, out loud, read. In circle W, diameter PQ is 34 inches. Chord AB is 30 inches. Find T to P. Find all possible angles and arcs in the diagram. Let's start with what we know to be true. It says right here, the diameter P to Q is 34. So if that's 34, instantly we know that half of 34 is 17. From W to P is also 17. We're told that A to B is 30. If perpendicular, then bisect, which means each of these are, of course, 15 and 15. Find all possible arcs and angles. And you're like, what can I find? And we're ultimately wanting to find TP, which is only a little segment. So when you're stuck, you always want to either look for or make a right triangle. And remember, all radii are of equal length. So I could take this QW and I can move it anywhere that I might find useful, which in this case would be right here. Why is that useful? I now have a right triangle. Have two sides, need third side, Pythag. So that black squiggle, I can find X. And then from there, I could find the yellow TP. Then to find angles, I can use inverse SOHCAHTOA. D. Read out loud, finger on paper. If a bicycle wheel has a diameter 26 inches, how many times will it revolve riding 26 miles along Coyote Creek Trail from San Jose to Morgan Hill, round to the nearest rotation? Let's get our information here started. First off, it's a diameter of the wheel is 26 inches. So 26 is the diameter, inches. Took care of that. We're going to be traveling along a road of 26 miles. From San Jose to Morgan Hill. We're asking, how many times will the tire revolve? This is the really important thing. Think of this as a tire. When it revolves, I'm not rolling on the diameter. When a tire revolves one complete rotation, it moves forward. And it moves forward, a complete rotation is one circumference. So that's the key to this whole problem, is understanding the word revolve actually means circumference. So your first step here is to find the circumference, which is C equals D pi. Finger on paper, read out loud. At the park, there's a pool shaped like a circle. The ring-shaped path goes around the pool. The radius of the larger circle, while the path itself is an unknown feet wide. We're going to put a non-skid coating on the path. The SureStep coating, which is right here, covers 120 feet squared per gallon. You can only purchase whole cans, so the number of gallons must be a whole number. Catch this, watch it carefully. The cans cover feet squared, and yet the units involved are yards squared. Automatically, you should understand the buzz language that 1 yard squared, 1 yard by 1 yard is 3 feet both ways. Therefore, 1 yard squared equals 9 feet squared. Keep that conversion in mind. After we find out how many cans, we're going to calculate the area of the pathway, then the number of cans to coat the pathway twice. The can of coating costs $29 per can. Ultimately, it comes down to money, which anything important usually does. Comes down to money. First order of business is, how many square feet is that pathway? Really simple here. To find that pathway, we have the area of the larger circle and the area of this inner circle. Once you have those two areas, you can see all we're going to do to get the donut is subtract. Larger circle minus smaller circle gets this pathway that we are trying to find. This 30-second video link shows the sport of autocross, which is the highest participation motorsport in the world? My father participated in autocross for close to 40 years. He won the national title for his class of a car in 1979. And his class includes, this is a Fiat Spider 850. It's called the Mouse. It runs on Hoosier tires. The edge-to-edge diameter of the tire is 20 inches. This is the actual dimension here. The edge-to-edge of that tire is 20 inches. The average autocross grid is approximately 3/4 of a mile in length. During competition, the Mighty Mouse will generally run 3 runs. So part of your calculations of cost is to figure out how many sets of tires are you going to need for the entire year with this in mind. So you first want to figure out how many times that tire is going to revolve, how many revolutions for a total of 3 runs in a 3/4 mile course. In other words, how many tires, how many revolutions will there be in a single competition? And we established earlier the idea of rotation is the length of the circumference of the tire. So your first step is C equals D pi. And you're going to find the circumference of that tire. And keep in mind, when you find the circumference, it's going to be in inches. And you're going to calculate how many rotations fit in inches in a 3/4 mile course 3 times. That's going to be the start of this problem. Yes, there are conversions involved. Do not know the conversions involving inches and feet and miles, I recommend you take a look at your unit conversion chart. There's one side that involves feet, inches, and miles, commonly called the English system, in quotes. Honestly, it's only the Americans that continue to use it. And then on the other side is the metric system. You are required to know all of these unit conversions. Question G says circle Q has endpoints of a diameter at S -3, 2 and 5, -4. Graph these points to the right. Find the exact center of the circle using the midpoint equation. Find the midpoint of the diameter and label it Q. So I essentially walk you through the problem. So let's have these 2 points first on the grid. So we have S at -3, +2. And we have T at 5, -4. And it is a diameter. I recommend you use a straight edge for this. We want to find the equation of that circle. So the circle is roughly here. And midpoint of that diameter is going to be the center of the circle. Therefore, you're going to go through the process of finding the equation of that circle and put that there at the bottom, of which you need both the center and the radius. Now, this part here says you're going to take a ruler and graph a tangent to circle Q at point S. Tangent at point S. I'm going to graph a straight line. And we want to find the equation of that line. So y equals mx plus b of that green line. Trick to this whole problem is this really simple. If tangent to a radius, tangent to the radius, right angle at the edge. You need to keep in mind there's going to be a right angle right here. So whatever the slope is of this diameter, you need to find the slope of that green line and then find the equation of that line. For this problem, you're given a bunch of measurements, which we will place on the right side. You're going to find all possible arc measures, and you're going to find the inscribed angles, and then find the central angles, identify chord, secant, tangent, find all tangent to radius angles, which includes a right angle. You want to find ultimately all angles and arcs. So taking a look here, we're going to color code this piece of information. AB is going to be 5x. And BC is 3x plus 30. CD is going to be 6x plus 10. DE is 2x. EF is going to be 50 minus x. FG is 6x plus 12. And then GA is going to be 4x plus 8. And of course, the trick to the whole problem is when you add all the arcs together, they're going to equal 360 degrees. So you're going to solve for x, find all those arcs, and then start working your inscribed angles and your central angles. If tangent to a radius, if tangent to a radius, if tangent to a radius, right angle at the edge. So right here, if, keep this in mind, tangent to a radius, if tangent to a radius, there's going to be a right angle at the edge. So we have lines y equals 3, is all the points where y is 3, and that is a horizontal line. So that's y equals 3. And then we have y equals -5, which is down here. And then we have x equals -2, which is a vertical line. -2. We're going to graph a circle E in quadrant 3 and F in quadrant 4. Which are tangent. We want a tangent to all 3 lines. Okay, so here's quadrant 1, here's quadrant 2, clockwise, counterclockwise. Here's quadrant 3, quadrant 4. So we want one circle whose center, okay, center of the circles must be equal distance to all 3 lines. Keep that in mind. We want the center of the circles in quadrant 3 and quadrant 4. And the circles must be tangent to all 3 lines. Ask yourself, where does the center have to be? One of the centers is here, somewhere in quadrant 3. So you know the center is somewhere here of one circle. And the other one has to be somewhere in quadrant 4. So we know its center has to be somewhere over here. They must be equal circles, tangent to all 3 lines. So in the diagram to right, a circle is inscribed in a square. The diagonal of the square is 12 centimeters. Find the area in exact terms. So we want the area of the shaded region, which essentially is going to be the area of the square. And then you're going to have the area of the circle. And of course, to get the area of the shaded region, you should be able to see that to get the area of the shaded region, you simply subtract the area of the circle from the area of the square. That is going to get you your shaded region. And the piece of information you've been given is the diagonal of the square is 12 centimeters. So the diagonal of the square is 12 centimeters. Trick to this whole problem, of course, is to ask yourself, what kind of triangle are you rocking right here? What kind of triangle is right here? So that's obviously a very important kind of triangle. And it's going to give you pieces of information that you need to figure this problem out.